Do you know those calls you receive when considering to change your telecommunication provider? You get chased up, receive special offers. This is data science. In this video, I want to talk about how data science projects translate into business processes and also about the challenges you should be aware of. My name is Anna Gründler, I'm a lecturer at Heinrich Heine University, and in this video series I aim to demystify data science and put it in the context of management practice. I deeply believe that for every business person it's important to understand the general idea of data science, even if you never intend to apply it yourself. After identifying a use case and data to address it and finding a suitable model, the model needs to go into production. But let us start with a tough one. According to a survey, more than 85% of all data science projects never make it to production. Reasons are manifold. It can be the technological infrastructure. Is the server capacity limiting, or are there any third-party tools used? Another one can be the availability of data. Is it web scrape data or external data, or it's coming from silos in the organization? Another one could be feedback mechanisms. So the model quality needs to continuously evaluate it. Or is it proper access mechanisms? Are there any restrictions? And also talent. Is someone there to monitor that model? And lastly, legal aspects. To tell you a real story from a pharma production company. Well, they had machinery data and developed a nice machine learning model that was able to predict outages. And when a decision was made to bring it into production, the team realized, well, the only way to access the data would be by manually extracting it. And this does not scale, and it could have been anticipated beforehand, right? And like this one, most of the issues can be anticipated beforehand, which shows the importance of considering deployment or production from the very beginning of a data science project. See the video on use cases if you want to learn more about it. While developing an initial model can be quick, deploying it into production entails a lot more steps. What do I mean by that? A typical data science project in a larger sense starts with a proof of concept, then moves into a minimum viable product, and then into production. The proof of concept POC model is the minimum needed to prove value. Often this model is performed on static historical data, and typically the model is not connected to live data inputs or end-user systems, like the machine in the pharma company. If the POC is successful, the next step would be a minimum viable product, MVP. Here we see a wider range of features and a more robust code. However, data inputs and model outputs are often connected manually to the model still. The production model, or the automated robust model. In this case, data input flow into the model automatically, for example from a data lake, and model outputs flow automatically into end-user systems. Very robust. So a successful data science or analytics project would be integrated into the enterprise IT ecosystem, but also embedded into business processes. And this means that certain ways of working are adjusted. In an optimal world, as a next step, the solution should be deployed at scale, for example, in additional business units or in additional geographies. Back to the initial example, the calls you receive from the telecom provider. Well, their model probably predicts that you would be fed up and think about going away. Scary, isn't it? But they also know from the data that a special offer could let you stay. And why are they doing this? Well, experts say it's much more expensive, 5 to 6 times more expensive to retain a customer than getting a new one. On a more structured note, a business problem could be customers that are leaving. The use case could be that it would be helpful if we could predict that customers leave. Then we can formulate a churn problem and predict the probability that the customer leaves in the next month or so. It can be a logistic regression to calculate the probability if customers leave based on certain attributes. Could also be a decision tree, by the way. Input data could be customer activity, gender, age, or external factors. As a business, then the business process should change. For example, sending out advertisements or special offers to the customers that are going to leave automatically. So data science is more than just a niche. It is an essential part of digital transformations when approached holistically.